Alright, hello. So I received a help request on problem 3. So let's take a look and see what we have in the code that I received. So 7.3 is just an update of our duct buoyancy problem from within the chapter. And so we're just going to have a spherical object, and we're looking at, now we're going to be given the depth for which it's submerged in the liquid and asked to calculate the temperature. Right? So it's just our buoyancy problem where our force balance reduces to this. So I believe here the subscript not refers to the object. So that's 4 times the density of our object times the radius of the object cubed, right? All of which were given. Then here's the density of the liquid, R naught, the radius of the object again, and the depth of submersion. All right. So we also know D. Okay, so we know this whole term. Okay, our one unknown here is rho L. Okay, so in theory you could solve for rho L analytically, and then if you wanted to, rho L is just a function of T. Rho L is given by this equation where A, B, C, and N are all parameters. So in theory, if you solved for rho L analytically, you could then solve analytically for T. All right, but the thought is let's get this set up so we can use F0 to solve directly for T without doing any of that. Okay, so here's our force balance. Okay, rho L is just a function of T, right? So you can think of rho L and T being, say, equivalent. It's just in terms of T, right? Rho L and T aren't linearly related. Okay, so it's a nonlinear equation that we're going to have to solve. Okay, so let me grab me, and let's look at the code that I was sent. Okay, so I sent this force balance. This is a script. All right, I have this anonymous function defined up top. There's an input of rho E, and it's going to call force balance with input D, and then it's going to jump to, okay, so what it looks like is, let's look at force balance D, right, but my guess is they're trying to solve for rho L, and then they're going to try and analytically solve for T, okay, yeah, it looks like they did quite a lot of work to get there. Okay, so let's take a look at balance. Okay, force balance, input of D. Then here's the density of my object, the radius of my object, and my force balance. Okay, yeah, so there's my force balance is given. Okay, just an input of D. Okay, the issue is if I look at this, right, so there's D, D's my input, rho OO, R naught, but this rho E, right, rho E is not known. Okay, rho E is going to be the density of my solvent. Okay. So just for starters, rho E needs to be listed as an input there. And if I come over to buoyancy, okay, that must be the rho E is also an input there. Okay, save that. Okay, now the other thing would be, okay, if I'm reducing force balance to single input rho E, D needs to be defined. Okay, so let's just say rather than defining it in my command window, okay. Let's say depth of object in centimeters, and I had a couple test cases. Let's look for the case of say 180 centimeters or 80 centimeters. Let's just say 80 centimeters. Okay, so now I have depth defined. You could have done it in my command window. So now I would define this anonymous function rho find, which is going to have a single input of rho E. And what it's going to do is, when I pass it that value of rho E, it's going to call force balance with D, which is defined in my workspace, and also pass it that value of rho E. Okay, so then that all goes to force balance here. So rho E, all right, we're going to essentially, that's going to be our unknown we're solving for. We pass the value of D that we're given in the problem set. There's my force balance. Okay, so F0 will keep systematically guessing values of rho E until it finds the rho E that satisfies that equation. Okay, cool. Okay, but now as I look at F0, okay, this range, okay, that range corresponds to the range of temperatures. Okay, and what we need though is the essentially range of densities. Okay, so I'm just going to copy that, all right, because I'll maybe try and get this working with T. Okay, so for rho find, rather than using that temperature range, let's use a range of densities. Okay, and I didn't solve using densities, so I have no idea. Okay, but let's just guess 0.1 to 100. Check, 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 and let's see what happens. Okay, and so now in theory I can just run this. Buoyancy 73. Okay, hey, I get a temperature out, right? And so what that looks like then is, it must have worked. It solved for density, rho L. Okay, actually let me unsuppress that. Okay, so our density was actually 0.8253, and they get negative 219. Okay, let's see, that was for 80. 80, I say negative 54. Okay, so what is 273.15 plus T, right? Well, yeah, so negative 54. Well, now I need to work on my my mental math, right? Because this would have solved for temperature and this would have solved for. I need to look at the units. Let's see. Where T is the temperature in Kelvin. It should give me the temperature in Kelvin. Alright, so when I run buoyancy 73, I get negative 219. That should actually be a 219 Kelvin. Because it would be, the conversion would be T minus 273.15, right? So I must have a sign here in solving. So it looks like you get the right value, but there's a sign error somewhere. Okay, so it looks like you get the right answer, but I'm guessing there, perhaps this negative sign shouldn't be here. Okay, because there's no way you get a temperature of negative 219 Kelvin, right? That's impossible, right? But what's interesting is, that would convert. If I just, say add that to 273.15, I get 54.1430. All right, which is the correct absolute value of our answer, right? So my guess is there's just a sign error there, right? Because it should be T plus 273.15 gives me my answer, right? But, no, T, right, minus 273.15. But, I don't know how to say it. Like, the fact that T plus that gives me this correct magnitude, I'm guessing there's just, some sort of sign error business going on, okay? But that's okay. We can actually fix this animal up, all right? And so what I'm going to do is, I'm going to update row find so that rather than having row E as an input, I'm going to make T an input, Because then what I'm going to do is, once I have T, I can calculate row E, all right? So let me copy these constants here. I'm going to make T my input because once I have T, I can calculate row E via this expression. Right? So you use the notation row E is equal to A, and I just need the A times B raised to the negative 1 minus T divided by C it's a negative 1 minus TC, and it's that term raised to power n. So I make T an input because once I have T, I can just calculate row E via the density equation, and I just copied those parameters from the other side, or from the script. So these I don't need here. Okay, there I don't need t here then, and what I'll do is, let me comment this out. Okay, t will be equal to F0, I'll keep it row find, and now I can give it that temperature range to search over, right? So this is going to be my temperature in Kelvin. So if I want temperature in C, that would be my temperature in Kelvin, minus 273.15. Bam. Okay, so if I try and run this again, well, let me have it display the final value. If I run this again, I get negative 54.1430, which is what we should get with 80. All right, so let's try 180. Should be 243. So if I were to run this for 180, save it, bam, 243. Yeah. All right, success. All right. So what I did is then I just updated it so T became an input, because once I know T, I can use that to calculate row E, right? And so figure F0 is going to keep iterating or guessing new values of T until it finds the T that satisfies this equation, right? And so once it guesses the value of T, I can just go ahead and calculate row E directly, right? This is also a good example because when we were getting negative 219 Kelvin before, it looked like the expression as it was worked out looked correct, but oftentimes I find the more you try and simplify an equation or work out some analytical details like that, the more likely you are to make a mistake. Okay. The other thing you could do if you really wanted to beef this guy up, right? One thing I might do is, like heck, you could package these up together. Let's make buoyancy 7.3 a function. Okay. So just in the interest of having fun, okay, and as you keep beefing it up, in the interest of having fun, take it one step at a time, right, to make sure we have things working right. Okay, and that, and then this is just going to be res. All right, so now I have a function that just takes d as an input. Okay, suppress it. Now I have a function that takes d as an input and returns the temperature in degrees C. Okay, cool. I've got it packaged up, so now I could just send off this one file if anybody wanted to do a similar calculation.